We're going to do the first question. The first question over here reads that you got to define what velocity is. So velocity is basically displacement. It's a vector quantity. So remember, not distance, but displacement with respect to time. That is what velocity is. If they had talked about speed, then speed would have been distance over time. Now, the drag force D acting on a car moving with a velocity V along a straight horizontal road is given by this. So you're given this thing where K is a constant and A is a cross-section area of the car. Determine the SI base units of K. So first thing is we're going to write this down. K is force, which is FD divided by the velocity. I think V is velocity. So I mean that's V. V is velocity, V square. And you've got A. What is A? Is the cross-sectional area, so that's going to be meter square. So it's going to be V square A. So I'm going to just write the base units now, and the base unit is, the first thing is how do you measure force? Force is mass into acceleration. So we're going to calculate the base units of force first. So it's mass into acceleration. So mass is m in grams, and so let's put kgs. Meters per second square, that's acceleration. So it's meter s minus 2. Acceleration is the change of distance or change in velocity with respect to time. So kg, and it's got ms minus 2 and divided by velocity square. Velocity is meters per second or s minus 1, but it's squared, so it's meters per second squared. And the cross-sectional area A is meter square. So I'm going to simplify this now, and this should come out to be equal to kg. And it's going to be, if I cancel out the m's, it's going to be m minus 3. That's about it. So that's about that's a base unit, and that's going to be our answer to this question. Let's do part C now. And the value of K in SI base units for the car in B is 0.24, and the cross-sectional area A of the car is 5.1 meters per second square. The car is traveling with a constant speed along a straight road, and the output power of the engine is 4.8 into 10 to the power 4 watts. Assume that the output power of the engine is equal to the rate at which the drag force D is doing work against the car. Determine the speed of the car. So we need to figure out the speed, and everything is kind of given. I mean, this is the formula. So we need to figure out the speed of the car, which is V over here. So it's going to be I have to figure out FD first. So that is, they already told us, assuming that the output power of the engine is equal to the rate at which the drag force is doing work against the car. So it's equal to the rate at which the drag force is doing work. So that's what. So energy is or power is work done over time. And we can further write this down as power is force into distance. Force into distance is energy over time. So what he's saying is, he's given us the power, which is 4.8 times 10 to the power 4. So he's saying, assuming that the output power of the engine is equal to the rate at which the drag force FD is doing work against the car. So we figured out FD over here. That's the output power of the engine, which it's doing per second. So we're going to use that, and we're going to put that value over here in the formula. Now, if we start doing the calculations, it's going to come out to be what? Where's the original formula? I'm just going to do this with the original formula, which is we know what FD is. That's given over here. That's 4.8 times 10 power 4. The V velocity has to be found out. We know the A, the cross-sectional area of A is given as 5.1 meters per second square, and K is also given that 0.24. So if we try and solve this would be 5.1 divided by 0.24. And then we're going to take the under root, and that is going to give us our velocity. So if we do this on my calculator, this would come out to be equal to it's going to come out to be equal to